Okay, hello everyone. This is Sasse from iTelescope. We have started the sky tours again, which is really exciting. So we got a bit of countdown. I'm just testing the audio. Just put in comments and make sure that you can hear me. So if you don't know how to do this, you can you can comment by logging in with Google onto YouTube. So Google and YouTube are connected. It's very easy to do. The instructions will follow on the screen, so just try and do it. And I've got also a moderator now. I run another Eagle channel, by the way, Sasse Photo, and one of my moderators has jumped in, so she's going to help. Thank you, Nicole. So I hope the audio is okay. Anyway, I'll talk to you in about 2 minutes. We're going to start, and thank you for joining. Hello. I hope you're all doing well wherever you may be. So we are now broadcasting on Universal Time. So my name is Sasse and I am doing sky tours again, which is quite exciting. I'm the astronomer in charge for iTelescope. I'm just going to adjust my screen a little bit here. Just give me a second. So this should be fine. I hope you can hear me, that the audio is okay. So we're now live, and today we have a very exciting topic. It seems like with the advent of Gaia and many very sensitive instrumentations, there's nothing more to discover for amateurs, right? And it's not the case, as you see. Josep Drudis, who is an affiliate and a very keen astroimager at iTelescope, has done some amazing imaging recently, and we're going to interview him together with the co-verifiers of this image. And it's very exciting because it's an emission nebula, and you'll see something that is quite surprising. But before we do that, I wanted to show you a little bit about what you can see in Australia. So you're going to see, let me just get this screen right here. 1 second, I will switch my screens in a moment. I have to multitask. So let's see if we can do this. Get rid of this screen. Okay, there we go. There we go. So you can see you can now see the participants in the background. But before we do that, I'm just going to show you what the Australian sky looks like, because it's quite exciting. If you've never been to Australia, this is the view that you get. And I can see some people have jumped in. NASA Jet Propulsion has jumped in. That is great to have you on board. Wonderful. So this is, why is why is the Australian sky so exciting? We who live in North America think our Milky Way is great, but wait till you come to Australia. This is the typical picture that you get if you do a 30-second exposure. And it's quite magnificent. What you see here is something really unusual. It looks like a cloud on the right. I'm just going to zoom in there. And that is the Large Magellanic Cloud, very common for people who live on the southern hemisphere, completely unknown to people who live on the northern hemisphere. And what you also see is the clarity of the sky. What we call seeing is absolutely amazing. And you will see the Milky Way, you see these incredibly dense dust clouds almost appearing three-dimensional. And what is also beautiful, as we move into June now, you will see the center or the core of our Milky Way right up in the zenith. So you can look straight up. It's the most beautiful time of the southern hemisphere. And I will explain to you where we're actually going to go today. I'm going to zoom in on my picture. So that is a 30-second exposure that I took. And as I zoom in, and I will do that, I'm just going to get myself out of the way here. So now you can see it much better. So this is the photograph of that's the Magellanic Cloud that you see there. And as I zoom in, you see this very pink bright spot. We have nothing equivalent on the northern hemisphere. And I'll show you the equivalent that we have is the Orion Nebula, and I'll show you everything in a moment so you can see it together. But that is the famous Eta Carina Nebula, a gigantic emission nebula that is the birth of many stars, young stars, really beautiful and very distinct. You can see it with the naked eye. You can actually see the reddish on a very clear sky. And that is in the constellation of Carina. And Carina means the keel. That's where it comes from, the keel of a ship. If you look at this very bright star here in the middle of the screen, that is Canopus. That's Canopus. That is after Sirius, the second brightest star on the southern hemisphere. And as we zoom in, that is the beginning of Carina. And if you draw a straight line in the direction of Carina, you come to this very fuzzy object that you can see. I'm going to zoom in here. And that is an open globular cluster. And there's another bright star that, let me just zoom in again. There's another bright star that you just see about 10 o'clock from this very bright globular cluster. And we're going to speak about it in a moment. And that is also part of Carina. But now comes a small object here, a very small object. And you can see it. It sort of looks yellowish reddish. It even comes out with a DSLR. And that's the nebula we're going to talk today about. It is called IC2220, quite a crazy designation. Very small, but you can clearly catch it. So that's the beautiful southern hemisphere. By the way, here you can see the Coalsack Nebula, very dark nebula. So we have dark nebulas, we have emission nebulas and reflection nebulas. We'll talk more about that in a second when I introduce our guests today. And what it actually looks like if you stand and you look to the south, every 30 minutes you will see the sky move, and you can see the rotation very clearly. And you can see on the left side, you can see Sagittarius. That is the beautiful part that we see upside down from the northern hemisphere. If you go as low as Florida, Hawaii, Texas, and so on, you will be able to see Sagittarius rising, especially in August and September. But on the southern hemisphere, it's much more magnificent because Sagittarius keeps on rising through the night. And you can see how it rotates and it goes right up into the zenith. And you can see Eta Carina and the nebula that we're going to talk about. And then you can see the small Magellanic Cloud. And if you put all this together into one image, you get a very fractal image. It is putting all these together, superimposing it, you get this beautiful fractal pattern. And if you look in there, you can see that is indeed where the South Pole is, where I'm zooming in right now. So that's the South Pole. And that gives you a good idea. And the beautiful patterns that arise this way are because you have the Eta Carina Nebula there moving like a big, gigantic cosmic clock. And you have the beautiful Sagittarius rising on the left and then moving to the right, exactly like the handle of a big clock. By the way, at the bottom, what you see there is Australia's biggest telescope. It's a 4-meter telescope, 3.9 actually meter. And if you ever want to experience something really wonderful in Australia, do join my masterclass. Just go on the iTelescope, and I do these masterclasses. You'll be able to enjoy the most beautiful skies in the world. You can see my camping van up there. I came first with a camper van and did all these images. That's, I think, enough of an introduction. If you do want to, what I did want to show you for the Northern Hemisphere very quickly is if you stand at iTelescope right in the middle of the telescopes, and let me just get this screen up 1 second. My computer a bit, yeah, there we go. You get this view. I'm just going to zoom in now. You get this beautiful view. That again is the Large Magellanic Cloud. There, that here where I'm pointing my cursor is Eta Carina. And if you go then towards the south-southwest, this is a constellation you will recognize immediately. And there's only something weird, it's upside down. You can even see the Orion Nebula there. There's the Orion Nebula. But you can see the size difference already between the tiny Orion Nebula in comparison to the Eta Carina Nebula. And that's just to give you an impression. And there, by the way, is Sirius. If you see this star here, that's Sirius, the brightest star. And it's also upside down because on the Northern Hemisphere, we're used to having Sirius below Orion. Well, welcome to Australia. Everything is upside down, and at least from my perspective, in many ways, a lot more exciting. Okay, so you see the telescopes, they're just at, this is probably taken around 6:30 a.m. The telescopes adapting to the temperatures, the roof opens, and the excitement of the night sky starts. Good. Well, so what I'm going to do now is I'm going to introduce our 3 guests, and I'm actually got them live on Skype. Okay, so we have a bit of an echo there. 1 second. Whoever's had that, plus please put your microphone down. I think we have a feedback somewhere. Right. We have a feedback from the main channel. So somebody is looking at the iPhone and just 1 second.
Yes, and I actually got the
Yeah, we just have an echo problem. Just hang on a sec. One of you, that's better. One of you is listening to the feedback, and it seems to be coming in. Let me see why this is happening. Okay, hang on. Maybe it's myself. Maybe I'm the culprit. Hang on. I think I'm the culprit. I am the culprit. Let me just switch off mine. I think I'm the one. Sorry about that. This is not easy to do. Okay, I think we got it now. We got it. Okay, so I have 3 special guests today. I have Josep, who's in the middle there, and he is the contributor of this wonderful nebula. And then the other 2, there, Andrea has just disappeared. That's Andrea Luna from Italy. And all of these are doctors, by the way. Every single one is a highly educated doctor, and they have many talents. So it's an honor, pleasure to introduce all of you. Andrea Luna, Pizzetti, right at the bottom of the screen from Italy, and from the top, I have Tel, and I have to, gosh, I forgot your last name in all this hurry now, Tel.
Lekatsas.
Oh, thank you. That's a Greek name, right?
Yeah, it's a Greek name.
It's a Greek name, yes. So anyway, it's very nice to have you 3 there. So maybe I'll start off with Josep. Tell us a bit about the image, and I will try in the meantime. I'm just going to try and get your image in. So Josep, please go ahead and introduce yourself. Thank you.
Thank you, Christian. Well, I think that already with the introduction that you sent in the newsletter yesterday, I think that this is everything more or less said. I'm originally academically, I'm a chemist. I got a Master of Science in Chemistry and a PhD in Chemistry many years ago, and also a Master of Science in Astronomy 14 years ago. So I have been imaging for many years, and this is an image that I really did not expect to get any kind of special discovery, of course. This IC2220 is a reflection nebula, but it is an unusual reflection nebula because it is red-orange. Usually reflection nebulae are blue because of the light dispersion. And in this case, it is a red-orange due to the central star that is really brightening this nebula. This star is an M-class star. This means that this is a red giant, about 5 solar masses, so a big red giant, and that's why it is red-orange. So, but anyhow, what I tried to do is, or I wanted to do is to get some, just in case some red nebulosity was in the background, I wanted to get it very clearly, because sometimes when you image, so all reflection nebulae are usually only imaged with LRGB, so luminance, red, green, and blue. And in this case, I also took H alpha because I wanted to get very neatly this potential background nebulosity. To my surprise, the H alpha, and this is the image I took. This is an integration of 21 images of half an hour each, meaning that this is about 10.5 hours of integration. And then in this image, sorry, Christian, I'm having a
echo. I can hear that.
Echo, yes.
I don't know where that echo is coming from at the moment.
Well, anyhow, don't worry.
Okay.
So in this image, what I saw is that there are 2 bubbles that were not imaged before. So I had not seen those bubbles before in any of the images, but they were here in the H alpha image. I additionally took oxygen 3 images, so just to see whether this bubble was also active in O3, but it was not. So the O3 image, this is the final color image in which you can see the Toby-Jug Nebula, which is the central nebula, which has a very nice structure, but you can also see very faint the bubbles.
And Josep, tell us a little bit, because you're talking about reflection nebula, and typically we would expect them to be blue, the same color of the sky, and so on. So why does this have such a peculiar color?
Because usually the reflection nebulae are brightened by they are reflecting the light coming from very hot, usually class O stars, very massive, and they are blue stars. But additionally, the blue star becomes bluer because of the light dispersion. So the light that is reflected by the dust is usually, so dust absorbs the red light, and then in this case the reflected light is usually much bluer.
I'm just jumping in quickly into one of. Oh, you got so many. We'll go through them in peace, but I just wanted.
You want to get the M20? No, the M20 is not here.
Okay, sorry, I'll get the M20.
You wanted to take it from my website.
Right. Okay, you're right. That's the Trifid Nebula. Okay, fine. Sorry, I will. Now I've lost your flow. I will go back to this image. And I'll try and find it in the meantime. Okay, but that's your telescope. Let's talk a bit about the machine in this telescope. This is quite a menacing thing. Yes?
This is not exactly my telescope, but this is the telescope I use. This telescope belongs to Don Goldman. I am his telescope partner. This telescope is located in iTelescope in Siding Spring Observatory in SSO, and it is an excellent telescope. It has an excellent camera, wonderful filters. Actually, it is two telescopes in one. So you can see the 20-inch, which is 51 centimeters for the Europeans, and it also has a TOA 130, which is a refractor just on top of it. Yeah.
Now, why would you need that?
Well, when from time to time we switch from the big one to that one, and then we start imaging for several months. We start imaging in wide field, and then then afterwards we go back to the big one, to the CDK 20-inch, and that's it. So we are swapping, and now currently we are using the 20-inch again. So no problem.
Right. So yes, go on.
No, it's okay.
It's okay. Well, fine. But let's go to this image here. This is a very strange-looking image. So tell us something about this.
Well, this image, this is the result of an idea from Andrea Luna. This image. So Andrea Luna said, well, we should probably confirm that the bubbles that we see in H alpha are really only H alpha. So when you image in H alpha, you always see the H alpha emission, but you also see the fraction of the continuum emission that falls in the 656 nanometer of this filter. And then what she suggested is to subtract the red from the H alpha image. And this is the result of it. So the dark bubbles are really in the H alpha and not in the red.
Right, and
So
that makes complete sense. That makes complete sense. Yes.
Yeah.
Just maybe to explain for those who don't know what H alpha means, maybe we just give a little bit of background where this comes from. So we have three types of nebula, and I was just trying to find the famous Trifid Nebula. If I can just bring up, let's see if I can just bring up Josep's. There we go. I'm just going to show very quickly here Josep's side. So what is amazing about this beautiful nebula is you can see blue, and you can also see the other colors very red. And maybe Josep, explain a little bit to everyone what the difference is between a reflection and a emission, but you also have a dark nebula here. So I think this is maybe an opportunity.
Right.
Go ahead.
Yeah, out of the four usual types of nebula, in this image you can see three of them. So the fourth one is the planetary nebula that is not depicted here. Here you see the emission nebula means that there is a gas cloud that is excited by the heat coming from stars inside it. So this is a warm nebula, and then it emits light, and it emits usually in the range of 656, which is the hydrogen alpha emission. This is the red one. The blue one is the reflection nebula, which is a cold nebula. It is not emitting in this 656 nanometer line, which is that it is the light reflected, the light coming from massive stars reflected onto a gas cloud with dust. And then so the red light is dispersed, and then you only have the blue one. But this is broadband. So if you try to get the blue reflection of reflection nebula with narrowband filters, you see absolutely nothing. So in this case, this nebula has been taken in narrowband with hydrogen alpha and oxygen filters, but it was also taken in broadband blue. just to also be able to grab the reflection nebula. And you also see the dark nebula, which is conforming this kind of structures, dark structures that you see inside the emission nebula, this one as well. And this is just very cold nebulosity and dust that is not being illuminated or excited by any star. So, and then it blocks the emission coming from behind it, and then you see it as a dark nebula, just as a dark nebula.
Right, absolutely. And we should also say that what's so interesting, of course, about emission nebula is that you need very hot stars for them, because you have to ionize hydrogen. So the whole universe is full of hydrogen mainly. And of course, there are many other gases, and you'll go on explaining about that. That's where the other colors come from. But the ionization is possible only with really hot and young stars. I mean, we saw this gigantic star Sirius, by the way. I was showing that would be a star that could easily cause emission to such a nebula, right? It has to be at least 10,000 Kelvin in order to cause this, right? So, so that's okay. Well, very nice. By the way, this is beautiful. This is a beautiful website here from. If you want to see top imaging, go to Drudis.com. This is his beautiful website, and you can see he's got a whole astro gallery here. Different galaxies, and he's also got the planetary nebula. That was the fourth type of nebula that he was talking about. But do have a look at it. It is absolutely magnificent. So let me just minimize this and then get back to our images. Well, maybe before we go on, let me see if I can just open the other one so we can see Andrea's images. 1 second.
I think that we should probably go first to the confirmation image.
Okay.
Can you please?
I can.
Go back to the four-panel image that we had before.
I can.
This one.
Yeah.
Here.
1 second. There we go.
There we go. The upper left panel is my image. So the hydrogen alpha image, inverted, of course, and very highly stretched to see the bubbles. But then once we believed or thought or saw that it was an undescribed nebula, then we needed a confirmation made by independent astrophotographers. And in this case, this was made by Andrea Luna Pizzetti, by Lekatsas, and also by yourself, Christian. Don't hide behind the screen, because you also contributed. And this one here on the upper right, which is the one you're showing now, is the confirmation image. This is an integration of 19 images of 10 minutes, taken with a 20-inch telescope and with a very sensitive camera, the 6303. And with this confirmation, of course, we could already say that the bubbles were real and not a reflection problem inside the telescope I was using or on the filters or whatever. So it's really, it was done with a different camera, with a different filter, with a different telescope, with and by different people. So it was perfect. So you three contributed to that. Thank you so much. And then the lower, so this is the image of the nebula.
Yeah, which one do you want to see first? Yeah.
Sorry?
Did you want to explain this one now or the other one next to it?
No, it's okay. This one, you can see the bubbles. So bubbles in this kind of nebula are not strange, so they are quite common. So this is a kind of nebula that is not a gas cloud that was on that region. So this is a kind of nebula that is created by the mass ejection out of a massive star. So there are stars that just are massive enough and they start, let me say, bleeding, so ejecting mass everywhere. This is one of them. So there wasn't any very big gas cloud there. And this is like, for instance, if you go to the lower right panel, Christian, this one, this is NGC 61, 64, and 5. And this is a kind of nebulosity that you can see when there are different events of mass ejection. In this case, you had a first event or first events, which are the blue, which conform the blue nebulosity. And then the second event, which is the big mass and thick mass ejection, which is the red one. This is, so NGC 61, 64 is the upper half, and 61, 65 is the lower half. I mean the red nebulosity. So, but then, again, if we go back to the other one, so in this nebula, you can see that the bubbles are really emitting in oxygen 3 because they are blue. But in our nebula, in IC 2220, this is not the case. So it's only H alpha, meaning probably that it was mass that was ejected very early and that it is simply excited and emitting only in hydrogen alpha, most probably by the central star.
Right, that's
it.
Which is a red giant, right?
Yeah.
Yeah. Okay. Very good. Well, thank you. I think that was incredibly detailed, and I hope that our listeners have. If you have any questions, by the way, just throw in questions and don't be afraid to ask. Okay. There's no such thing as a silly question, so please go ahead. And we'll be very happy to answer. So let's go and get Andrea Luna involved now. So I will just go to another folder. There we go. Okay. 1 second. Okay, Andrea Luna, please go ahead.
Hello everyone. This image is an image with it at Siding Springs Observatory with iTelescope network, and this is H alpha images, Y H alpha images, and we can see that there is emission near the central point that it actually is the nebula. And I've taken this kind of images just to see if there was some other around this nebula. Because the strange thing of the H alpha that there is just interstellar medium around this nebula, and so they
Andrea,
understand how it.
Okay, the audio is coming a little bit interrupted, so just speak very slowly, and hopefully it'll come across. I think we have some bandwidth problems. Okay, go ahead anyway.
I'll have I to repeat all the, or can I?
Okay, hang on. Just go on, please. Sorry, it's just a little bit difficult to understand. Just go on. It's okay.
Okay. Strange thing is that we were not able to explain why around this nebula, because this nebula is around M-class star, that it's not hot enough to ionize some medium. And so it's really strange. But we have to think that the interstellar medium that is probably around this nebula, it's very low density. So, and this kind of star are ejecting a very high quantity of mass with thermal pulses, and so it's probably that there have been 3 shock waves that could have heated the gas and ionized it too. And so we have emission. But in the images, this is a mosaic with different narrowband and filter I've done with iTelescope. And it's interesting to see that there is no trace of the bubble in the other filter. But the most interesting image is the one U filter. U filter is in the near ultraviolet light, and this kind of star should not have any emission in U band because it's too cold. But the fact that there is some emission, the U filter maybe maybe suggests that this star is going to soon.
Okay.
And I think
Yeah, Andrea, unfortunately, we are hearing bits. The audio is a bit poor, but maybe, Josep, can you comment a little bit? Sorry I have to do this, but it's simply because the audio is so difficult to understand. So she's obviously done incredible work here. She's got I can see helium, sulfur. I can see a red Z filter. I see the V filter, and I can see the sum of this. Could you please just comment? Sorry about this, Andrea. I'm not trying to be rude, but it's unfortunately not possible to hear you. So, Josep, can you just jump in a little bit?
Andrea Luna, what she said is that she tried to grab images through different filters. This is the helium 2. But if you go to the lower right corner, there's the U filter, and what she still more to the right, another one. Here we go.
There it is. Okay.
There is the U filter. And then what she was saying was that this kind of star is not hot enough, so the M-class stars are, the red giants have a very low surface temperature. And if the temperature is not enough to excite the surrounding gas and get a signal and give a signal here through the U filter.
Right.
And this is what we see here.
Okay. Well, thank you very much. That's incredible work. And she was talking about some surprise too, right? So that's.
Yes, but probably I could not hear her very well. And, Andrea Luna, if you think that you want to add something, could you please repeat that again?
Oh, I was just saying that it's very interesting to see some emission in the U band because, as Joseph has said, it's not used to. We don't used to see any U emission from M star. So this emission maybe could be a clue that this star is making planetary nebula.
Okay.
And
It's clear. Thanks. Yep.
Okay.
Very good. Okay, so let's, Andrea, is there any other image let me see, you've got quite a few here. I'm just going to jump quickly and make sure we have, because you have a lot of signs here. I don't know what this one was. Hang on, this flipped now. Well, okay. Well, let's move on then to tell. Okay, Andrea Luna, maybe. Sorry, I would have liked to introduce you to. Just tell us a little bit about yourself, to what you're studying. I think you have a very interesting background, and then I'll jump to Tel, please. I'm not sure if she heard me. Okay, I think unfortunately the bandwidth is not sufficient. So.
Okay,
Okay.
Christian, were you speaking to me?
Yes, if you could please say a little bit about your background, your studies, and so on.
I have a bachelor degree in biotechnologies, and I'm going to graduate in astronomy and astrophysics on this September. But it's been 4 years since because astronomy is the love of my life, and so.
Well, Andrea Luna, you post some beautiful pictures, by the way. Yes. So, sorry, I'm just going to explain because your audio is coming difficult over. But if you want to see some of Andrea Luna's work, go to the iTelescope Facebook page, and also sometimes on Twitter. But it's mainly we have a iTelescope.Net community there, and she posts many beautiful images there. So I just I had to add that. Okay. Well, thank you very much. Well, let's now jump.
Oh, thank you, Christian.
Thank you, and thanks. And sorry about the audio; it didn't come across so well, but I hope I did a little bit of justice here to jump in. So let's move to Australia now. We go to Tel Lekatsas. I hope I pronounced that correctly now. Tel, so it's over to you. You are the lucky person here who lives under the most beautiful skies. And the pictures I've just shown to you is nothing special, right? When you see the southern sky, right?
Yeah, it's true. I mean, I see that every night from my place. I'm a country doctor who lives on a cattle farm in Queensland. So I'm surrounded by cows, kangaroos. I've got echidnas. So it's really magical to go out at night and see the kangaroos hopping around while you're looking up under the Milky Way. So I see the Magellanic Clouds most nights. Not tonight because the moon's out. So, but you can still see them early in the evening. And I've been imaging for about 5 or 6 years now. I've got my own kit, but I like to use iTelescope first up because it's pretty cold tonight and I haven't got an observatory yet. So I saw Joseph's call for somebody to do some imaging on this interesting object, and I thought I'll give it a go. So I took about 6 by 10 minute subs and stacked them, and well, there's nothing there. But it does take quite a bit of stretch to actually sort of see some things there, and you can see it a little bit better in the inverted images. There's traces of it, but I'm really not surprised that you can't see much in an hour's worth of imaging. I mean, Joseph took how many? It was quite a large number at 30 minutes. So it's obviously the hydrogen alpha is very, very faint on this object, and it's a really good catch because no one's looked there, no one's taken that. Many of us would probably do an hour of hydrogen alpha on this object and say, well, there's nothing much to see, I'll go look somewhere else. So I find that very interesting that he got a very deep image and he actually found something there that no one else had actually seen before.
Well, you actually know that he didn't find it. It was his daughter, so he doesn't get any credit, okay?
More impressive.
Yeah, he's got an amazing daughter. That's the one she gets the credit. That's why it's called Anna's Nebula. Joseph, can you just comment on that quickly, how your daughter got involved? I mean, this is so fascinating.
Yeah, well, actually, she was... So I was pre-processing the images with CCD stack, and then she just jumped over, and then she said, well, let me play with that. And then she was stretching that image more than usual. And then the bubbles were there. So when I saw that, I said, wow, I have to work this much better. And then it all started.
Well, that's absolutely marvelous. By the way, with which telescope did you take this?
This was shot with T30.
The T30, right?
About the same time as you did. I think your session was right after mine. I remember watching your session as I was shooting mine. I thought, okay, this is good. Someone else is doing it too.
Yeah, all three took the images with the same telescope, T30.
T30, that's it.
Yeah, so this way, it was much easier to integrate all images in only one.
Now, you could have, of course, argued if T30 also had an artifact, then we wouldn't have known, right? But it's very unlikely. That's why you have to confirm
very unlikely that it would have been exactly the same that we had with the other telescope.
That's very nice. Very nice. Is there anything you want to add? What is your passion about in astrophotography? What do you usually do, and how did you get into this?
Usually, I'm trying to image comets, so that's my main interest. So I prefer to use my own gear for comets because you can get lower elevations with your own stuff.
Yes.
So at the moment, I've only recently moved to my new place, so I'm in the process of getting a pier made and building an observatory. And hopefully I'll get a few more comet images. I haven't been able to in the last 12 months, but that's my main interest. I like deep sky as well, but and I like chasing after something unusual. So if there's a new nova or something, I like to try to take an image with my own gear and with iTelescope. So
what type of gear do you have? I'm just curious.
I've got a 120mm refractor,
right,
and I've got a 8-inch RC8 and an 8-inch RC. Cassegrain, Ritchie Creation, whatever. So and just my own mount. So and I've got a CCD camera with hydrogen alpha filters and LRGB. So I don't use the hydrogen alpha much because I'm mostly going after comets. So maybe an oxygen 3 for comets.
Well, that's nice. And what are your? Do you take any nebula or so apart from that?
Yeah, I've got some nebula images floating around. I do like the planetaries. I've got a lot, but it's like most of it's sitting there unprocessed. Big stacks of unprocessed data. So but I'm happy. I do like the planetaries as well.
Well, very nice. So I think finally let's look at some of Josep's images because they're absolutely beautiful. So Josep, back to you. Can you comment on this marvelous image, please? Go ahead.
Well, this image is IC 2948, which is usually called the running chicken nebula. I have not yet understood exactly why.
Where the chicken is, yes.
The running chicken nebula, but it's very well known with this name. This image is the result of many images because this was taken with a 130 refractor. So this is a 3 by 3 degrees image. But I had already taken some specific parts of this nebula with a 20-inch. So this image has been, enriched with the high-resolution images, with some high-resolution images coming from the 20-inch, and they have been blended here. For instance, the central part of the nebula where you can see some black spots. This one here, the black spots are the Bok's globules.
There you go. Very nice. Very nice.
Yeah, this resolution you can only get with a 20-inch. So this was blended here. Also, this if you can go here to the left, there is a very bright star here on the right-hand side. Sorry.
Oh, sorry, the right. Okay.
On the right. Yeah.
There. Okay.
Here you have an inverted V nebulosity here. If you can see to the right-hand side of this bright star. Here. If you can please zoom out a bit. Yeah, here we go. This nebulosity was also taken with a 20-inch, and also parts of the nebulosity on the right-hand side, two small round parts. If you can go to the right, please. Here. Yeah, this was also taken. This also is a blend with higher resolution images. And then if you go down, there are also just here. Yeah, this was also taken with the 20 inch. So this is the result of, I think it's 5 different images.
My goodness. What's the total imaging time for everything? What do you think?
Well, I should go to my website to see it, but probably 50 or 60 hours.
Wow. Well, you could see, I mean, it just shows what you can do if you go very deep and you do beautiful image processing. It's just absolutely marvelous. So let's jump to the next.
This was done, okay. Everything it was done with narrowband filters.
Everything with narrowband. Okay. And
with the only exception, with the only exception of the stars. I always take the stars in RGB.
Right. Yes. By the way, I teach that thanks to you on the masterclass. I teach a lot of your wonderful tricks. So if you want to image like and learn how to do this like Josep does, you can come to the masterclass, and that's exactly what I show there. So go ahead, tell us a little bit about this one.
This one, if you can please zoom out to see the whole image. This is a mosaic. This is a 2x2 mosaic. So this image is about 5 degrees square. This image was taken together. It was a joint project that we did with Don Goldman. And it was done at the end of, I think it was around August and September of 2017. And this is also narrowband, together with LRGB, just to be able to catch the nebulosity. The central band of the galaxy, the star band of the galaxy. But then the narrowband allows you to see a lot of detail in the nebulosities that you have in the Large Magellanic Cloud. And for instance, this is the Tarantula Nebula with several different nebulosities around it. You have to take into account that we took the mosaic with the refractor. So this is wide field. But we inserted or we blended, but about 15 different high-resolution images inside this Large Magellanic Cloud. So the total exposure that has been blended here amounts to 145 hours.
Oh my goodness. You are incredible. I said crazy, but you're incredible. I mean, come on.
Anyhow, I love this picture.
Of course you do. You're brilliant. Absolutely brilliant. Really.
And this picture was selected as an avid in January 2018.
January 2018. I think you have, if I remember correctly, a total of 6 or 7 apods already. Is that right? Astronomy picture of the day.
It's five apods and 7 amateur apods.
Really? Oh my goodness. Okay, let's jump to the next one. Let's see where we go. Oops, it doesn't want to jump at the moment, so let me see. If I jump back to here, let me open one and see if we can do it this way. Okay.
This one I love it too.
Oh, sorry, I jumped. I jumped by mistake. 1 second, Josep.
Yeah.
I don't know why. There we go. No, let me just jump to where it was. Wait a second. Where were we? No. Where was it? Come on. And I went right to the end, didn't I? There it is.
Here.
Yeah.
Well, this everybody knows. This is.
And I did it again. Sorry. Here, come. Yes, I'm trying to make it bigger. So there we go. Okay.
This is a mosaic. In this case, 1 by 2. This is a 2-panel mosaic. This is M16 on the top, M17 in the lower part.
There's M16.
And this is a deep image taken with the refractor, also with high resolution images of M16 here, as you
you can recognize this. Yes.
The pillars of creation.
Yes.
The so-called pillars of creation. And then also blending a high-resolution image of M17 in the lower part.
There it is.
Yeah. This image was also selected as an avid. That was August last year.
Incredible,
just
incredible.
2 or 3 days after the eclipse. So,
Really?
yeah.
Oh. My God. And what was the total exposure time of this composition?
Well, that's a good question, but probably about 50, 60 hours.
Good.
Because you have to take into account that it's 2 panels, so each panel usually is about between 15 and 20 hours, and then you have to add the high resolution images, probably even more than 60 hours.
Right. And this is a famous one. Here you go.
That's very well known,
Yes.
M27.
Beautiful.
This was not taken from Australia, because its declination is about plus 25, 27, and this is so it is. You can watch it from Australia, but it's too low.
Too low. That's it.
This image was taken with a Schulman telescope in Arizona. This image was taken during a workshop with Adam Block, so he was commanding the telescope, of course, at that time. And this is LRGB plus H alpha.
And you can see the ultra alpha beautifully on the outside, right? That's
correct. That's correct.
Yeah.
I have to say now I have the opportunity to take some images with a telescope located in the northern hemisphere. And it is located in California. And the first image that I have taken is, so I have started just a week ago. The first image I took was M27 in oxygen 3, because this was a filter that was not present in the Schulman telescope.
Right.
And now I have not processed it yet, but I want to process now the LRGB plus H alpha and O3.
So that'll be a new image. I haven't seen that before. Okay, now
it's very common.
Now comes something really curious. NGC 1316. What are we looking at here?
Right. This is a galaxy that is called. So its normal name or its nickname is the Galactic Killer. So it's a galaxy that has absorbed and teared off many different galaxies. It is now in the process of eating the lower galaxy, which I don't remember its name, but I think it's NGC 1317. But you can see here in the core, you can see the remains of other spiral galaxies. So these are the dust clouds that are usually in the core of the galaxies. And this image is the same core, but taken with a 2.2 meter in the European Southern Observatory in Chile. This is taken with a 2.2 meter. And the next one, if you can go to the next image.
1 second, I'm trying. There we go. Yeah, there we go.
That's the same one, but it's the core taken with a 20-inch.
That's incredible.
So which is not bad compared to the 2 meter.
I cannot believe how you did this, Josep, because let's go back again. If you look at the core here, I mean, I don't know, maybe they have a more high resolution. Well, I can't expand it.
They have a high resolution.
But I'm sure, that's absolutely incredible. It's absolutely incredible.
Now, the explanation is easy. Their image is much better than mine, of course, because they have, at least only because they have a very large telescope. But so I was conscious that I wanted to stress so I processed this image in a way so that we could much better see the core, the structures in the core. So I took some time, shorter exposures, so the HDR, higher dynamic range, just to get a better glimpse of the core. and then I specially processed the image so that we could stress out these structures. So these fine dark nebulosities that are in front of the core.
Incredible. Okay, and now comes the curious one.
Oh, this one! I love this one too. This was also an avid just a few days ago, so 3 weeks ago. This image is a planetary nebula, so this is also narrowband, but this image has a very specific setting. So this was also an image that we took together in a joint project with Don Goldman. This nebula has a very strong emission in oxygen-3, which you can see with the blue color.
Right.
Some emission in H-alpha, which you can see here. No, it's not this one. Just below the central star.
In the center.
Yeah, here. This star, by the way, the central star is a double star, a double white dwarf. This pink emission is the hydrogen alpha emission, and then it has two jets. The upper jet, the lower jet is quite faint, so we are not seeing too much from this emission. But the upper jet is emitting very strongly in nitrogen.
Oh.
Too.
Okay.
And well, as long as Don Goldman's telescope has a beautiful set of different filters, it also has the nitrogen. So I tried with nitrogen, and that's the outcome.
And you would not see that with sulfur, right?
No, it is not sulfur. Nothing to be seen in sulfur.
Interesting. Really beautiful. Really beautiful.
And this is narrowband only.
Okay. And
well,
now,
here we go. This is one of my favorites.
Of course, it's beautiful.
If you could please zoom it out, thank you. Mm-hmm. This is also a 2-panel taken with a 20-inch, also only narrowband, but this is in narrowband not only hydrogen and oxygen. This is hydrogen and oxygen and sulfur. Why did I take additional sulfur? Because it's red. Well, I usually map this kind of emission nebula with hydrogen is mapped to red and 15% blue because of the hydrogen beta emission. Oxygen is mapped to green and blue, and sulfur is mapped only to red. So all the regions that you see here, which are strictly red, they are very strong in sulfur. All the regions that you see slightly magenta, they are strong in hydrogen alpha, and all the regions that you see in greenish blue, that's oxygen 3.
That's
it.
And you basically invented this type of mixture to give it a more realistic look, right?
Well, you start trying everything. So my goal here was to try to reproduce the nebula spectrum. So the spectrum of this nebula is very strong in those lines, but then you have to reproduce the intensity of those lines. And this was the combination that gave me the result that I considered it to be the best. But this is always subjective.
Well, it's a beautiful subjective thing, whatever. It's
the advantage of having taken this with the 20-inch is that you get a very high resolution.
Okay.
So this is NGC 6164. You already saw it, and we explained it before. So it's a mass ejection nebula.
Okay, we'll go to the next one.
I like very much mass ejection nebula.
Yes.
You will see another one.
Good.
Later on. This is NGC 6188 plus NGC 6164.
Right.
In the lower one.
Right.
You can see it here. Right. This is a wide field. The central part, which is usually called the Fighting Dragons of Ara. Ara is the constellation where this nebula is located. This part was also taken with a 20-inch and then used to blend it. I blended it here and then you have a higher resolution in the central part.
Beautiful, beautiful.
Which is this one. This is the higher resolution image.
Right. My goodness.
Yeah, I like very much this image because here, now you don't see it, but if you can go higher, here. The bright star, around the bright star, there are a lot of nebulosity of bubbles, but they are very active in oxygen. And this is very nice. I like this part very much.
Wow.
Because there is a lot of structure in the oxygen 3 image.
Beautiful. And now comes something. It's 6302.
This is a very small and tiny nebula called the Bug Nebula. This is NGC 6302. And this is usually, so of course you have seen many times the Hubble telescope image, which is much better, of course. But this is worse than the Hubble telescope, but it's mine.
But it's amazing that you actually got that level of detail. I mean, it's.
This is a nebula that is so nominally this nebula has about 3 arc minutes inside. It's 3 arc minutes inside, but this is a deep image, and so from one extreme to the other one, it's about 7 arc minutes.
Oh my goodness.
So usually the image is the red region, which is a hydrogen alpha region. But then when you take a deep oxygen 3 image, then you get the other one. So
now another
is an image that I like very much.
Yes, and now something completely different. So what is this?
That's totally different. Yeah. That's a project. Well, I like, Christian, that you wanted to bring this into this session, because this is a project that we did jointly with Christian. So in this case, it's a joint project with Christian.
So what is it about?
This is a galaxy. So the galaxy, the small blob that you can see here in the center, it's a galaxy with a redshift of 6.70. So this galaxy is about 12.8 billion light years away.
Isn't that amazing, right? Isn't that amazing? And what is so amazing, you may have to explain, Josep, what you mean by redshift, because, and also what it actually means, why this image is so difficult to take.
Well, probably everyone, but at least most of the people that can be seeing this already know what is redshift. But it is related to the expansion of the universe. Mm-hmm. So when the Big Bang started, then immediately there was the inflation period, and then the expansion period, which is still lasting today. Then you have, at a certain point, the sky or the universe was transparent, and then the radiation could go through, and then we start seeing things just after that period. Then there was the reionization period, and the reionization period is a very interesting period because it's very close to the Big Bang, still close to the Big Bang. It's about more or less a billion years after the Big Bang. Now we are 13.8 billion years after the Big Bang, and this is the light. So the light coming from this galaxy. So this galaxy is receding from us at a very high speed. So we are receiving this light. The light that we can see in this image is light that left that galaxy 12 billion years ago. So I don't know how this galaxy is today, but most probably it's not like this.
Yeah, and that's exactly the exciting thing, isn't it? That you don't need a huge telescope to capture something like that. It's more about the camera, because the redshift is so immense that you have to have a far red sensor. And in this case, it's actually a backlit, very sensitive sensor to catch this very tail end of the redshift. So I think what we did is we tickled out everything we could out of the CCD sensor.
Yeah. Well, actually, this image, I took this image in a project, I had a project. I was imaging many different quasars, and then when I saw Christian's image of his quasar that was 6.40 something.
Yeah, 43. That's right.
Redshift,
yeah.
In Redshift. Then I said, well, why not trying another farther away? And then I got that image with 670. And then Christian popped up, and then he said, well, why don't we join efforts and then we take deeper images? And then this is the result of one of those images. We got 7 times the farthest objects ever taken by an amateur telescope. This galaxy here has a redshift of 7.0112, which is at this moment, this is the farthest object that has been taken ever by an amateur or by amateurs. We both have also another image of a galaxy that we think that it belongs to a galaxy that has a redshift of 7.48.
Exactly.
Which is still much farther. Anyhow, this has not yet been confirmed.
That's it.
So this is confirmed, but the other one is not yet confirmed. If you go to the next image, this is, so remember this image, the galaxy here, and then this is the image taken with the Sloan Digital Sky Survey. So this is exactly the same image that we have there. And then if you zoom out, please. Here we go. No, it is not here, the redshift. But anyhow, if you go to the SDSS, then you will see that this has a redshift of 7.01.
Yeah, exactly.
So quite far away.
And that's the difficulty that we have.
Can I ask?
Go ahead.
What filter you use?
Sorry?
Joseph, can I ask, is that a luminance image or red band?
That's only luminance, taken with T17. T17 has a wonderful camera, which is backlit, and therefore it has a sensitivity compared. So the usual cameras, the APG, the anti-blooming cameras, have a sensitivity comparable to ISO 1600. This has a sensitivity of 35,000.
Wow.
So really sensitive. And also it is very sensitive to infrared, to near infrared.
Yeah, so it's actually not a luminance filter.
Because the Lyman alpha line is the light that we are capturing here. Lyman alpha is 127 nanometer, so which is far away in the ultraviolet. But when it recedes, it goes to the infrared, and then this is 1,000 nanometers.
Exactly. So it's not actually a luminance filter; it's a clear filter.
That is the name of this quasar.
Oh, it's up there. It's let me see what
the name of this one. This is not a quasar. This is a galaxy.
A galaxy. Okay. Yeah.
Well, a quasar.
Oh, it's not a quasar.
A quasar is a galaxy.
Well,
so the quasar is just the active nucleus of a galaxy. But but this is a whole galaxy.
I thought that it was.
Yeah, this is a whole galaxy with a very active core region. And the name of it's a very boring name. It's a capital J with the coordinates on it. So nothing else.
Okay.
I can send it to you. No.
Thank you.
Yeah, okay, so that is taken with T17, so that's the telescope I actually own at iTelescope, so anyone can have a go with it. It also has a grating, by the way, so it's really meant for scientific purposes and crazy things like these. So it's not an imaging telescope. Okay, very good.
Okay.
Well, I think that brings us more or less to the end. Let's just take one beautiful image so that, tell us something about this, and then we will...
This one is also a mass ejection nebula. This is RCW58. This is a very nice nebula. It is not a planetary nebula. It's just a mass ejection. and it is, as you can see, the hydrogen alpha emission is the strongest, but you also have a halo that is very active in oxygen 3. But if you zoom out a bit, please, you will see why I found this was taken before IC 2220.
Right.
And then here I was able to grab some of the background red nebulosity on the right-hand side. You can see the upper right-hand side.
Right, right.
So this was what I was trying to get with IC 2220. And I didn't get it, so I got the bubbles.
That's incredible. I've many of these images I've only seen in your in your library. I've not seen them anywhere else, so it's quite incredible. Really beautiful. Well, okay. I think that slowly brings us to an end. I think we've had a really exciting session, and I've seen the chat has increased, so that's very good. I would like to thank Josep Drudis, of course, for this incredible lecture also, and insight into what it takes to do really top imaging, which is quite fantastic. Andrea Luna, thank you so much for participating. Sorry about the audio problems we have, but I think the contributions that you have done there are quite incredible. And maybe one day, we'll take a direct telephone line or something so we get your audio back. But I definitely would like to have you back on the show with more details, especially about the work you are doing. So it's very nice. And thank you so much all the way from Australia. It's past 3 a.m. there. So how you do it? Astronomer's life, but you're not only an astronomer, you have a normal life.
I'll go for a stroll outside now and have a look at the sky. Thank you.
Well, anyway, and I just want
to.
Oh well, thank you so much, and I also want to say a quick thank you to all our viewers. Thank you for participating and enduring quite a heavy science lesson here. So you can see there's so many details, but you can also see what it takes to take such images, and what Josep does. Actually, anybody can do. It's all about passion and dedication. And on that note, I wish you a wonderful weekend. So I'll be off to Australia on Thursday doing the next masterclass, which I very much look forward to. And then next year I will continue, by the way, with masterclasses. I won't be doing any more this year. Usually the space is very limited. If you want to join, send me an email, Christian@iTelescope.Net. I haven't got my email in there at the moment, but have a look on the iTelescope website. You'll find masterclass, and then you will also learn some of the techniques that Josep is using, which he has kindly passed on to me. Really brilliant techniques, which will enable you to actually get to the top of what an astroimager can do nowadays. So in that sense, thank you very much for participating today, and thank you to all our viewers, and have a lovely weekend. Thank you.
Thank you.
Thank you.